So today I want to show you how to find a cross product. First of all, the cross product of two vectors is another vector as opposed to the dot product, which we found last time, and the dot product is just a number. This vector, three components, i's, j's, and k's, this vector has a special property, and that is that it is a vector that is perpendicular to both of the original vectors. That means it's at a right angle to each of them. And you determine the direction that that vector is pointing based on the right-hand rule. And so the right-hand rule is if you grab your right hand and you point your fingers towards the first vector, and you turn your palm towards the second vector, then your thumb is going to point in the direction of the cross product. Let me show you with GeoGebra a second. So in this tool, I have two vectors. I've got vector u shown here and vector v, and in a moment I want to show you what their cross product is. And so we can turn this around a little bit. If you can imagine your fingers of your right hand pointing towards u, and then rotating your palm so that it's upward towards v, at least the way that I've got it oriented right here, then your thumb should point off in this direction. And so let's look at what the cross product is. So there's the cross product. And if you look at it just right, it's at a right angle to u and also at a right angle to v. And it's the only vector that would have that property, that it's perpendicular to both of them. Now, to calculate the cross product is a little bit of a procedure. To find the cross product, there's a couple different ways you can do it. If you're really good at memorizing formulas, you can use this guy. That doesn't work for me, but it is available, and it's how you could program it into a computer or calculator or something like that. Another approach is that you can use the 3x3 determinant that we learned earlier this year. If you set up one vector here, the second vector underneath it, and then have a vector of I and j and k at the top, then you can find the determinant. That's the one that I remember most often, and so that's what I often go to. And I'll show you another technique that you can use in a little bit too. So first of all, let's find a vector perpendicular to A, which is 3, 7, 0, and B, which is 0, 1, 5. And to begin, we can just use this beast of a formula. So what this means is take the second component of A, which would be 7, and the third component of B, which is 5, multiply those together, and then the third component of A, which is 0, and the second component of B, which is 1, and multiply those together, or effectively 7 times 5 minus 0 times 1. That gives us 35 minus 0, and so the first component of our vector is 35. The second component of our vector is, well, the A3 times B1, and I'm not going to read all that, but that's a 0 times a 0 minus a 3 times a 5. And so that ends up being 0 minus 15, or a negative 15. And the third combination, if you want to find it a second, you can hit pause and do it, or I'll bring it up in just a moment. That's 3 times 1 minus 7 times 0. And so 3 minus 0 is 3. And when you combine all those things together, final answer, A cross B, is this vector, 35, negative 15, and 3. Again, that's not my favorite technique. I'm not very good at memorizing that whole formula. And so here's that same question again, but this time we're going to use the determinant definition. And so the determinant, we're going to put 3, 7, and 0 in these places, and 0, 1, and 5 in these places, with an I, j, and a k on top. And the technique that I use to find the determinant is I just write 2 copies of it back to back. So here's the first copy, 3, 7, and 0, and 0, 1, and 5. And then I'll just do that again over here. 3, 7, and 0, 0, 1, and 5. And then I do a bunch of multiplications. And so I am going to do this multiplication, and this multiplication, and this multiplication. I'm going to add those all up. And so let me type that a moment. That's 7 times 5 is 35i, and 0 times 0 is 0j, and then 3 times 1 is 3k. And then I have to do a series of anti-diagonals, or subtracted values. So we'll do this diagonal times this diagonal times this one. And pull those in a moment. That would be 1 times 0 is 0i, so I'm going to subtract 0i. And then the next one is 5 times 3 times j, and so I'm going to subtract 5 times 3 is 15j. And then 0 times 7 times k, that's minus 0k. And when you combine all those things together, 35i minus 0i and so on, we end up with the same vector we had last time, 35i minus 15j plus 3k. And for me, that technique works a little bit better. But it still requires that you remember the determinant, and maybe you've never even learned the determinant. So here's one more technique that's kind of interesting, and I will show it to you, and you can use it if you want. So if we just look at I and j and k, remember I is a step in the x direction, j is a step in the y direction, and k is a step in the z direction. And if we just find their cross product using the right-hand rule, it's kind of interesting. So if we point our fingers towards I, and we, that is with our right hand, remember, and cross our fingers from I, rotate them around to j, or put your palm towards j, then the cross product would be k. And so that means that I crossed with j is k. By the way, if we do I crossed with I, that's not so obvious, but your fingers and your palm, they can't really both point in the same direction there. And in general, some vector crossed with itself is always just 0. And then I crossed with k. If you point your fingers towards I and point your palm straight up, then your thumb points in the opposite direction from j. And so we would say negative j. If you go in and fill in the rest of this table, j crossed with j is 0, because anything crossed with itself is 0. And so here's another one. J crossed with I ends up being the opposite of I crossed with j, and that would be negative k. And, well, I can't remember all of these that quickly. So I want to show you a little mnemonic that I've been taught to figure out these pretty easily. And that is this little circle wheel here. If you go I crossed with j, you end up with k. If you have j crossed with k, you end up with I. And so that's this one here. I can fill in. And k crossed with I, that ends up being j again. So that's down here. If you ever have to go backwards through this wheel, then you have a negative cross product. And so we already saw that I crossed with k gives us a negative j. K crossed with j, which is our remaining one in the table here, is a negative I. And so that wheel, I think, is the easiest way for me to remember which ones crossed with which are positive and which ones crossed are negative. Anyway, let's see if we can use that to help us find one more determinant. So here is one last determinant, and I want to multiply 2i minus 5j plus k crossed with 5i minus 2j and 3k. And to do this, we're just going to use regular algebra rules. This is a giant distributive property problem. So we're going to distribute 2i with 5i and negative 2j and 3k. And so let me type that in here. And so let's see, 2i times 5i would be 10i crossed with I. 2i times negative 2j would be negative 4i crossed with j. By the way, vector multiplication is not commutative, and so it's very important that you keep these in the correct order, I crossed with j. And see, the last multiplication there would be 2i with 3k, so that would be plus 6ik. And next, we need a few more multiplications. Let's multiply negative 5j by each of these. And so negative 5j times 5i would be negative 25ji's, j crossed with I. And let's see, completing this, we have 10j crossed with j. And then we have negative 15 jk's. That's funny. And finally, we have to cross the positive 1k with each of these terms. And so k crossed with 5i would be 5 ki's. And k crossed with negative 2j would be negative 2 kj's. And k crossed with 3k would be 3 kk's. And now's when our wheel will come in handy, because each of these different expressions can be replaced with something. I crossed with j can be turned into a positive k, and the kj term can be replaced with a negative I term. And so let's take this a moment and do some replacements. 10i crossed with I, that term just becomes 0. 4i crossed with j, that's going forward for the loop, so that's going to be replaced with a k, and importantly the sign is not going to change, it's a positive k. I crossed with k, that's backwards through the loop, that's a negative j. Or if I rewrite this a little bit, that's going to become a negative 6j term. Continuing on, j crossed with I is going backwards through the loop, and so that's going to be the opposite value. So that's going to actually turn into a positive 25k term. J crossed with j is another plus 0. jk is going forwards through the loop, and so that's going to be replaced with an I and not change the sign. ki is also going forwards through the loop. That'll be replaced with a j and not change the sign. And then kj, that's going backwards through the loop, so I'll replace that with an I and, more importantly, change the sign. And finally, 3kk, k crossed with k is just 0, and so this is another plus 0 term. And then I can combine like terms, and we'll be done. So the zeros can be ignored. We've got, let's see, there is a negative 15i and a positive 2i, so that's a negative 13i. There's a negative 6j and a positive 5j, so that's a negative 1j. And finally, there's a negative 4k and a positive 25k, and so that is a positive 21k. So there is a third technique for finding vectors. If you'd like, you could also find this with the determinant method or with that formula. But honestly, calculating cross products of vectors is sometimes tedious, and so I find it easier to program it into either a spreadsheet or use GeoGebra or use a calculator program to do it. And so I'll be showing you that in a future video. Thanks for watching.